There we go. Still wait a minute or so. So let's get started. I do want to talk about a few announcements, I suppose, or yes, let's do that first. So I'm going to go into Alex to do this. Let me make sure I get to the correct place. And what I want to look at first is, I'll come back to Alex in a moment. I see another document up here that I want to look at. Now, this is a really important document. I got to it by looking at or putting in my search field NWAC followed by academic calendar. So they have more than one calendar, but I picked this one to look at one important break that we have coming up. Our fall break right here, this fall break, is the 19th and 20th of October. So what does that mean? I believe that is a Monday and a Tuesday there. We're going to have a test number 2 before fall break. So test number 2, if you've looked on the calendar and Alex, is a week from Thursday. So I do want to make you all aware of that. So let's go into Alex here, looking at the main menu. And I've got a question to ask you in a moment. I'm going to write it down to make sure I ask you all. Well, let's go through this first. So let's take a look at the calendar. I like the 2-week view. So you will see what's coming up and when it's due. We have talked about transform functions. Today we're going to look at difference quotients, big function combos. But you will also see that the test 2 review no credit assignment is available as well. Now, technically, that assignment isn't due until October 15th. But you're not required to do it. It's not worth any credit. What I will say, though, is this test 2 review objective, if you have learned all 25 topics in that objective, and that or unlearn some of those topics, they're not going to appear. The only way that you will see all 25 topics is by doing this review no credit assignment. I'm going to close my door for a moment to the room because we've got, thank you, somebody came and did it for me. We've got 3 people remote in this house. So that's why this assignment is so important, because it has all 25 topics in it. That's one reason. But it has everything in one place. It's not as hard to get to all of the, it's really nice, and it's got resources there to help you remember what to do and so forth. So I wanted to point that out. Now, test 2, it's on October 15th. It's right before fall break. It's a Thursday, but right before fall break. So that is a week from Thursday. Hard to believe that that's coming up so quickly. I can't believe it. That's the halfway point of the semester. I don't know where the time went. Any questions on that? So I teach for NWAC full time. and I have lots of classes. There has been such a demand this semester that I'm teaching over full-time load right now. So, and it's also, I want to speak to the importance of when you contact me through email, it's really important to give me as much detail as you can about where you're having an issue with a problem, because otherwise I have really nothing to go, not much to go on. So for example, let me just show you in Alex. Let's go get a problem here. And while I'm here though, instructor resources is a great place to go. Here are my objective notes. You've got my notes here that you can refer back to. You see functions combos right here. I put the function combo one here. That's what we're going to talk about today. So you've got my notes. You can go back and review these notes. You've also got the test reviews in terms of what the must-see topics are, the 7 written work topics. Got the test reviews there. It's a very good place to go for resources. Now let me go into a particular topic. We'll see which one pops up for us, and we'll take a look at it. So we're not going to do this problem. I'm doing this mostly to remind you all of what kind of resources are available. If you go straight over to this over here, this is instructor resources. If you click on that, you'll see there's a video available there that you can click on. Those videos are from Arizona State University. They have a global online college algebra program that uses ALEKS. They've created some really good videos. So that's one place I may ask you if you have looked at it. And where's your first question? These other videos down here, 2 down from the top one, are the author's videos that are associated with the book that our course is based on. I like these videos better. I can tell you, much better. There is a dictionary here. Oh, sorry, that is the ebook. That is the electronic book, and there's a dictionary. And then let's take a look at this envelope icon. I'm going to click on it. So I am requiring all students that have a question that send me an email, send me the exact problem they're working on. Notice down here that this page has automatically been attached. Solving an equation that could be written in quadratic form, problem type 1. That's the exact topic that we have up here. But not only that, it's the exact topic with the same numbers and the same places and the same variables in the same places and so forth. So when you write me an email, and I'd rather you send it through ALEKS like this, you can attach your written work. And it's important that you attach your written work because it allows me to see where you might have an issue. And it will save time if you do this rather than take time. So you want to attach your written work, and I might ask for your written work. Anyway, so to save time for all of us and to get your answer as quickly as possible, it's probably best that you attach your written work here. You want to also, in that body of that email here, you want to list any resources that you've tried, because I will likely write you back and ask you, what resources have you tried already? And what questions do you have about those resources? Have you tried the explanation page? Have you tried the Arizona State University video? Have you looked at my notes? What have you tried? So I would like you to give me that. And also any specific questions. The more you can help me pinpoint where your issue is, the better it is. quicker you're going to likely get a response. Because when somebody just sends me, hey, I've got a question on this problem, my tendency is to, well, what resources, write back and say, what resources did you try? Because I don't know, I don't even know when to start. Or write back and say, send me a copy of your written work. So to speed up the process, it's just better to do that at the very beginning. So I would encourage you to do that at the very beginning when you need help. Or my other inclination is to say, how about coming to my virtual office hours, which are posted in Canvas on the main page. So I did want to take also some time to talk about what you can do in this course to likely get a higher test score. And one thing that I've seen that has worked for students, this is my 4th year teaching with ALEKS, and I've taught a number of ALEKS courses each term since then, including during the summer. And so I've noticed when I've classroom face-to-face classroom with students and teaching with ALEKS, I've noticed a lot about what students are doing in the course, because I generally walk around for 30 minutes of each of my classes, and we can't really emulate that here, unfortunately. And I look to see what they are doing. I walk up to their laptop or their desktop, see what they're doing, and see if they have any questions, or if I can see what they're doing and give them a little tip or trick or whatever. So I've seen a lot of what students do in the classroom with ALEKS, and I will say one item I've noticed about students that generally do very well in the course, they keep a very detailed notebook, some of them really thick, writing out every problem as they go throughout the course. That writing it out and being that involved, it's not a matter of just writing it out. It's when you're writing it out, it helps you be more involved, and therefore your likelihood of retaining the information, if you're really thinking about it as you write, studies have shown higher. So it's important to be as in the process as you can be. And if you keep a detailed, written, organized notebook, you can go back and review prior to a knowledge check or to an actual test or exam in this course. It's a real helpful tool. And speaking of knowledge checks, one of the other items that I have noticed in the course, what else I've noticed in the course, and I've gotten testimonials from students on this, is you said to treat the knowledge checks like they are actual tests. That at first, and I got a C on the first test. But after that C, I wanted to bring my grade up, and I thought I would take your advice, and I treated the knowledge checks like they were actual tests in the course, and I studied for them like they were tests or quizzes in the course, and I got an A on my second test in the course. So that's also a great way to prepare for the actual test in this course, is to use the knowledge checks as a test, treat them like an actual test, prepare for them like you would a test. And it's important to tell ALEKS that ALEKS sees exactly where you are in the course at all times, so that it can use its artificial intelligence to your advantage. So it knows. So if there's a topic that you have unlearned that you really need to know for down the road, it's going to be assumed that you know that topic down the road in this course, ALEKS will bring it up again so that you learn it, so that topic that you need, that any new topics for which that topic is a prerequisite, you will be prepared for it. So it's really important to tell Alex during those knowledge checks what you know and what you don't know. They aren't worth any points in this course. That's why they're not worth any course credit, because I don't want you to lose points on that. I want you to tell Alex what you really know, like the software was intended to work. And it's the only math software that I know on the market that uses artificial intelligence in that way. And it's really their claim to fame, to be honest with you. It is wonderful that they do that and are constantly monitoring you, because the idea is that you study for retention, like by having a notebook, and you treat the knowledge checks as tests. So by the time the final exam rolls around, you have retained most of the material in the course. So that comprehensive final isn't something to really get too stressed out by. So just make sure that you are filling in details here and giving me as much information about where you have your first issue with the problem, because I don't know I don't know where to start. And I'm not going to just write up the particular problem for you, because I've already done that in my course notes. So I've already done one of those problems, a problem just like that in my notes. So that's not what I'm here to do. I don't want to give you the answers. I want to teach you how to do the problem. So anybody have any questions? I'm trying to think if I've got any other tips that I can give you that come to mind right off of how you could do better in this course. And I'm sure that there are some, but the ones that I have mentioned to you are the ones that I can really think of. I would also encourage you to work ahead in the course. That's also another good tip. You don't want to wait, and I realize we all have different schedules, and some of us are just super busy that we don't get enough sleep and, and all of that. But if you can, I would encourage you to work ahead in the course. But not too far ahead, because remember, you're getting tests. You want to keep not work so far ahead that you're too far ahead of the next test in this course, because then that might mean that you're going to have to go back and study more for the test. So there's kind of a delicate balance there. So I do want to mention, let me come back there. I'm reading in the chat now. Okay, so Blair, I've never known the knowledge checks to go away unless you're past the deadline to take that knowledge check. And they're not supposed to go away.
So the other night when I finished the assignment, it went straight into a knowledge check, and I was like, oh, I had something else to work on, so I was going to come back to it Monday morning, and it wasn't there.
Okay, did you start the knowledge check?
No.
Okay, then it was after its due date then. You see what I'm saying?
Yeah.
So, and I don't know of any way of bringing that back, because they have due date. They only give you so much time to take those.
Well, yeah, of course. I guess I just thought I don't know. I thought I had enough time to take it, but I'll just make sure I take it immediately next time it pops up.
Or take some time to study, like for a test you would for a test before you do it.
Yeah. Okay.
Anybody have any other questions? So remember, you're also responsible for the content of all Canvas announcements, and that includes all the ones about testing. Since we have a test coming up, I will be given violations if I need to for test 2, test 3, and the comprehensive final. And that includes violations for not taking the time or not presenting your government issued photo ID to the camera. I believe you have and I'm going to double check this by conducting another test, but I believe you have the ability in Alex to redo almost anything. So if you don't like something which shows on the screen and you see you don't have your government issued photo ID on the screen, I believe you can retake it yourself. You may have it redo it. So it's up to you. You really would need to make sure you're getting a picture of not you, although they do have that step, but feel free to use that step as another chance to take a picture of your government issued photo ID. So you've got multiple times that you can do that. Since it is taking a picture, the webcam, it takes a bit of time. There's a delay on that. So you want to hold it up there for a while. And if you cannot get a picture of your government issued ID, or you're not sure, do not take the test. Contact me, because I can look it up and see. I can look it up and see if you got a picture of your government issued ID or not. I can review those all steps of that process at any time of that process. So you want to make sure that you're doing that. Otherwise, you're subject to a violation on that. And I don't want to give them out, but there's not a testing center in this country that you can walk into and not present a government issued photo ID to take a test. So that's what we're trying to emulate there. So you want to make sure you're doing that. Also, there is that one announcement. There are several testing announcements in Canvas, and one of them is that all of those steps that you can have by your side when you're taking a test, so you know what to do when, so you can get that test started pretty quickly, but only if you've got that government issued photo ID has been taken. You don't want to start the test. You want to contact me immediately. I'll be monitoring the test as possible on that Thursday. A week from Thursday, I've got 2 ALEKS classes that are taking their tests. I'm not doing any remote classes on that day. So I should be able, unless I'm working with another student on an email for another student or two, it shouldn't be too long before I get to you if you have an issue. The other one I want to mention, testing violation, you're not allowed to leave your seat during the test unless it is in an ultra emergency, like you're sick or something like that. And I don't want any of you to be sick, believe me. It's flu is starting to circulate, and we've got COVID, and I don't want anybody to be sick. So please take good care of yourselves and so forth. But if you're sick, and there are other reasons to be sick too, so if you're really sick, just let me know as soon as possible that that's what happened. So you don't want to leave your seat during the test. Once you sit down and start, please go to the bathroom before you take the test, immediately before. That's what I do between classes, just in case. So I think that's good. And the written work has to be uploaded within a reasonable amount of time. I had a student who wanted to submit it 2 days later, and I said, no, you can't submit it 2 days later. So I think that's the testing violations I can think of that stick in my mind the most, that I saw the most of for the first test. I will be definitely giving out testing violations for the second test and the third test and the comprehensive final, because I feel my Canvas announcements are very detailed, and be sure you read or reread those. So let's get started. Anybody have a question about the course in general? So I just wanted to let y'all know about fall break coming up. It'll give us some time off. I don't know about you, but I only teach remote classes Monday through Thursday. The test may be a bit delayed because I need to take some time off too, since it's halfway through the semester. So grading the test may not happen as quickly, so keep that in mind. I will try to work on them leisurely over the break though. So let's go and take a look at what we have in store for today. I will go down to my desktop and let's take a look at the current. It should be the current objective that we're working on right now. We are working on objective number 11, and these notes without the markups are currently in the software. I will put the notes in the software with the markups on them right after class. So I showed you where to go to instructor resources to get notes. And you have all of the notes there. So let's take a look. So what we're going to be looking at is we're going to have different functions lying around, and we're going to look at different ways of combining them, adding them, subtracting them, multiplying them, dividing them, and also doing a special operation with them, which is called composing functions. We can compose functions, and the process is similar to a artist working with clay, actually, and molding a piece of clay, taking the original clay, molding it. So, and then that artist wants to take that clay and output it to another artist for fun. And when that first artist outputs that clay, that next artist, that becomes input to that next artist. And that next artist molds the clay some more. And then that artist outputs that what he or she has done, and that output becomes an input to a third artist who then molds the clay, and so forth. That's really what function composition is like. It's the input output, then that output becomes an input to another function, and then it becomes an output from that. What's done to that input is done, and then it changes and it becomes an output, which is now can become an input to another function machine, and so forth. It's that type of process, really. So we're going to start by looking at sum, which is addition, difference, which is minus, product, which is multiplication, and quotient, which is division of functions. But before we get going, let me just talk about this and this. What does it mean in words? So this function notation here means, in words, find the y value of the f function when x is a certain number. That's really what it means. So this f means y. This g means y. This means, right here, this means find the y value of the g function at a particular x value. So these letters, F, G, H, S, T, W, and so forth, B, A, they're all function letters. They mean y. So you will see you'll see a lot of different letters used outside the parentheses. They all mean y. So what is the object here? The object is, typically we write our problem saying we want something like this. F plus G at a particular x, that x is the input. So this in parentheses, this x is the input. This F is the output. The x is the input. The F, which is the y, is the output. So typically we're given problems in this form. And that's not a friendly form. We usually convert to what we call workable form. So for this one, if I'm going to write down an F or a G, I want to write an X right after it. So for this, I want to do F of what? F of X. It's the only possibility. So F of X. Plus sign. G of what? G of X. So that's workable form. Subtraction. Same way. F of what? X. Minus, sign in between. G of what? G of X. Multiplication. Now notice multiplication has a colored in circle. Down below, we're going to talk about composition, which is not multiplication, and it's an open circle. It doesn't have any such thing inside it. So this is multiplication. F times G. F of what? X. Times G of what? G of X. Let's look at division, which is quotient. This is a quotient, but it's also division. So F of what? X. This is the division symbol. G of what? X. We convert it to workable form. Now keep in mind, this denominator, this entire denominator, can't be 0. Division by 0 is undefined. If I take my calculator and I put in my lucky number divided by 0, I get attempted calculation contains division by 0. Calculation fails. That's because division by 0 is undefined. And that's why we've got this, what's in the entire denominator, which is g of x. We're saying provided that that's not equal to 0. We're staying away from division by 0. And I want to just clarify, the entire denominator has to be 0 for this to be true. So these numbers you can ignore. So we converted these to workable form. Now we're going to talk about a special operation like composition, which is talked a lot about in art, like with modeling clay and so forth. We're going to change the composition of the clay. So let's look at this. Composition of functions. It's generally, the problems are stated in this form. And we need to put them in a workable form. This is a very user-unfriendly form. This does not mean multiplication. Multiplication would have this colored in. This is composition. So we read this F composed with G of X. We read this G composed with F at X. So the way we get the workable form is we look at this and first we see F. So we write down F and then we write down a parenthesis. Then we write down the next letter, G, then a parenthesis. Of what? X. And then we close off these two parentheses that we opened up over here. So what about this? How do we convert this one to workable form? And we're going to do, I think, enough problems today, so you'll have this down. We start with the first letter going from left to right, G, parenthesis. Next letter, F, parenthesis. Of what? X. And close off. Make sure we have the closing parentheses. So just to reiterate, this symbol here, this open circle, is not multiplication. If it were multiplication, it would look like that, colored in. So this open circle does not mean multiplication. It means composition. They're different. Multiplication is commutative. Composition is not commutative, meaning order matters in composition. The order in which artists mold clay absolutely does matter. You're not going to get the same, likely get the same output at the end if it's in a different order. So it does really matter. So function composition is not commutative. Function order matters. And we're going to see an example, at least one or more examples of that today. Now, maybe from your past experience in math, and I'm just going to jot myself down a note from it. I want to ask you something, and I wrote myself a note, and I just remember I need to ask you something. So let's just finish this particular introduction up. and then I will ask you the question. So let's look at machines here. Now, X is the input, no matter what. We use X for input when we're talking about functions. Now, we've got two functions lying around, this F and the G. And it depends on which order we use these functions. So let's start by using the function F first. So this X here is an input. It's an input to this function machine. And in this function machine is F. So whatever the F is, this F function machine is going to take whatever rule it uses, and that usually involves X, figure out what that is, and the output is going to be called F of X. In other words, the Y value when X is a certain value. Now that's the output of the F function machine. That output can now become an input into the G function machine. So we write down this F of X down here, put parentheses around it, and then that input goes into this machine, and whatever the G function does to it is whatever the G function does to it, and out comes G of that input, which is F of X, right here. Now that's a workable form. This is not the workable form, but I wanted to write it underneath it so you could see how it compares to the workable form. How do we get from this, how do we get the workable form? We take G, write it down, and then a parenthesis. Then we go over here to our next function letter, write down the F, and then a parenthesis. Then we put down the X after that parenthesis, and we close off the parentheses. That's how we get this workable form. Now, the other way that we could do this is we could input our X. This is another way that we could do function composition, where, remember, order is important. Function composition is not commutative. Order matters. So the other order, if we could investigate, is we could put in the X and first apply whatever the G function is. And the output would be G of X. Now that output can become input into the F function machine. And what would come out? Now we've got to write down our input to the F function machine, which is G of X, put it in parentheses, and then apply F to it. That's how we write it down. And what do we get? We get fog. Not really, but that's what it looks like, right? So we have, how do we write? That is the workable form. What does the given form usually look like? It looks like this, fog of X, right? So, and we could take this form and write the workable form, because we're going to be given problems with this kind of form. How do we get the workable form? We take the first letter, which in this case is F, parenthesis. This is the operation symbol, which means composition, so we ignore it. Then we write down G, parenthesis, of what? X. And then we close off the parentheses. That's the workable form. Anybody have any questions on this first page? I'll call it an introduction page. So I'm going to come up there for a moment because I have a burning question to ask you all. With regards to the test 1, were you able to see your every single question when you went to assignments in ALEKS? Could you review your test question by question in ALEKS? So the way you can go to the grade book in ALEKS to see your score on the test, but you can go to assignments where you actually took the test, and you should be able to review your test question by question to see what you got on each question.
I was able to review every single question.
That's really great. So that means I've got it set correctly. When did you do that, Luke? Did you do it recently?
I did it a few, or like the day after we got the test back, like very quickly after.
I see. I see. Thank you for that information. So you can go back, and that's a great study tool, because then you'll know what you actually got wrong rather than just knowing your score.
And I liked how it said, like, on the certain problems, like the written work, how many points out of the 7 you got right. So I kind of knew what I was doing right and what I was doing wrong on.
Thank you for bringing that up, Luke. You can actually go into Canvas and get more detail on the written work problems, because I marked them up in Canvas with the Canvas markup tools. So you could go into Canvas and click on the grade book in Canvas and take a look. Does that make sense? If you want to.
Yeah, and I saw it in Alex too for like the written work, but I didn't know I could see it like you doing it in Canvas. So thanks for letting me know.
Yes, I mean, this is all such a learning experience for all of us. So yeah, and I did take those scores out of Canvas and transferred them to Alex, so you'd have all of your scores in one place. So yeah, that's what I did. So I'm glad. That's why I wanted to bring that up. When I thought of it again, I put a big star by it on my notes. Okay. Anybody else have a question? Yeah, that's why I'm glad I brought it up. I want to make sure you all understand how this process works before we get to test 2. Okay, so let's go back down and do some questions, some problems. We're going to start out basic, and then we're going to go and then we're going to work our way up. I'm just writing down I want to make sure I know. Just write it down. I know what time the class ends. I just want to make sure I've got it down somewhere, so I'm constantly reminded of it. So let's take a look at this. We're going to start with sum, difference, and product of 2 functions. And then we're going to do a topic that talks about quotients. So we're going to do something we can relate to better before we get to composition. Suppose that the functions s and t are defined for all real numbers x as follows. So s of x equals 2x minus 3. So this is really the y value of the s function when x is equal to whatever it's equal to. And this tells us the formula to use to find s. Same with t. This is t of x. It's equal to 3x. This x is really, it's in a sense a variable in this context, but really what it means in this context is input. X means input, so X stands for the word input. We're going to be taking advantage of that soon later on today. So just X stands for input. All of this, for example, this S of X or this T of X stands for output. So the left-hand side stands for output. The entire left side stands for output. So the X is the input, the Y is the output. And in this case, Y is really S and Y is really T here. So it's important to know that what's inside those parentheses there is input, whatever that is. Later on, we're going to see something with a Y in it inside these parentheses. It's still the input. So what do we want to do first? We want to find the expressions for s minus t of x, the subtraction, s plus t of x, the addition, and evaluate s times t at a particular value of x, that is a particular value of the input, which is -2, at the input -2. So let's start. The first thing I think it's really important to do is you see this is stated to us as in the form s of x, s of x. This is stated in the form of t of x. So we want to convert to a workable form that involves those two. This is just shorthand right here. S minus t parentheses x parentheses here. So we want to convert it to workable form, something that's easy to use and that we know we get expressions where we can just look at them and know which one of these we want to use up here, and it's crystal clear. So we start with s. S of what? What's the input? X. S and t are output, so it can't be S or T when it comes to S of what? It's got to be the X. There's no other choice. This S minus T is the output. That's the output right here. So it's got to be X in here. So S of X minus T of X. It's not distributing here. That's not what it is. We can only distribute. We're not distributing. We distribute when we have multiplication over addition. This isn't really this is not multiplication here. It's not S minus T times X. So we can't distribute here. You can view it like that if you wish in your head. You can do that. But it's not really, that's not what's really going on though. So we have S of X and then minus from here, T of what? T of X. Now that puts this, that now looks like a problem that we can work with because we see S of X, we've got S of X up here. We see T of X, we've got T of X down here. So we can work with this. It's why it's called workable form. So we take out S of X, we replace it by 2x minus 3 minus T of X, which is 3x, minus 3x. And then we just combine like terms. So we have 2 minus 3, that gives us negative 1 or negative x, and then minus 3. So that's the answer for this, what they first asked for right here. So just to remind you, like terms have the same variable to the same exponent. And these guys really have an understood variable, well, not variable, understood exponent of 1. So that's why they're like. And then we have this minus 3 still left, which we have to copy over. So that's what the answer is for the first one, negative x minus 3. So now let's do this one, the next one, involving addition. So S of what? X. Plus, copy over, T of what? T of X. So we're just taking S of X and adding it to T of X. That's really all we're doing. So we're taking S of X, which is 2x minus 3, plus T of X, which is 3x. Combining like terms, we've got the x's are like, so 2 plus 3 is 5 what? 5x, and then minus 3. So lastly, let's take a look at this one. This is a little different because this doesn't have an x here, it has a negative 2. It works the same way. So we want S of negative 2 there. So we want S of what? Negative 2. Times T of what? Negative 2. How do we figure those out? Well, those are going to take us a little bit of work to do. We first want to figure out the y value of the s function when x is equal to negative 2. So we want to go to the S function and really just plug in -2 for x. So we get 2 times, plugging in -2 for x, we get 2 times -2 minus 3. 2 times -2 minus 3. We multiply first, get 2 times -2, which is -4, and subtract 3. We get, and if we do this calculation, we get -7. So S of -2 is -7. So we take out S of -2, put in -7 for it. How about T of -2? What's the y coordinate of the T function when x is equal to -2? So we go to the T function, 3 times x. X is -2, so we have 3 times -2, which is -6. So we take out T of -2 and replace it by -6. Take this out, replace it by -6. Negative times negative is positive. 7 times 6 is 42. So the answer for the last one here is 42. Any questions on this particular topic? That was just a warm-up one. So what we took a look at here, we took a look at addition, subtraction, and multiplication. Let's look at division now, which would be a quotient. Quotient of two functions, basic. So let's take a look. Suppose that the functions h and g are defined as follows. H of x is x plus 4. G of x is x plus 1. All of that times x minus 1. Part A, find h divided by g at -5. Let's do part A. So we're given in part A, find h divided by g of -5. Let's put that in workable form. So how do we do that? H of what? -5. Divided by, division symbol. G of what? Also of -5. Every letter needs to have really in workable form the number or the variable inside here that you're talking about. So let's evaluate. Let's find h of -5 first. That means we need to go to our h function and then put in -5. So our h function is x plus 4. So we're putting in -5 here, adding it to 4. So we get h of -5 is -5 plus 4, which is -1. Now we also need to find g of -5. So we go to the g function and plug in -5. Now we see x twice here. So we're going to plug -5 in for x here and in for x here. And I want to reiterate, this x really means the word input. So when we plug in -5 in the first factor here, we get -5 plus 1. We plug in -5 here, we get -5 minus 1. So we want to figure out what that is. -5 plus 1 is -4. -5 minus 1 is -6. Minus times a minus is a plus. 4 times 6 is 24. Now we still need to go back and figure out what it is we have. We need to go back here. H of -5 turned out to be -1. So we put -1 in the numerator. G of -5 turned out to be 24. So we put 24 in the denominator. This is our answer that Alex marked correct for part A only. If you have any questions, feel free to unmute your mic and speak out. I'm more than happy to take breaks to answer questions. take mini breaks. Let's take a look at part B. Part B says find all values that are not in the domain of h divided by g. What do you think we need to watch out for? What can't the denominator be? We can't have what number in the denominator? So the entire denominator can't be what? What number causes, what number in the denominator for g would cause problems? What can't we divide by on our calculator?
0.
Correct. So the entire denominator can't be 0. That's exactly correct. So division by 0 is undefined. And just to be precise, that means the entire denominator can't be 0. You can have like 5 plus 0 in the denominator. That's not going to cause a problem because the entire denominator would then be 5. But if that entire denominator is 0, it is a problem. So division by 0 is undefined. We are asked to find the values that are not in the domain. Just to refresh our minds, domain is a set of all x's. Range is a set of all y's. Domain is a set of all x's. So we're looking for the x's that would cause division by, make the entire denominator 0. Well, what is our entire denominator? How is it represented? It's represented in this problem by g of x. So we want to take our g of x and set it equal to 0, because that will mean that those will give us the x values, if there are any, that make the entire denominator 0. What is g of x? G of x is equal to x plus 1 times x minus 1. So I took out g of x and replaced it by x plus 1 times x minus 1. And we want to see if there are any x values that make this entire denominator, which that's a representation for the entire denominator, and we want to see if there's any values of x that make that entire denominator equal to 0. We're going to use the zero product property, which we've been using quite a bit before, and to figure out where this product is 0. This just represents a real number, as does this, and the only way you can multiply two numbers to get together to get 0 is if one of them is 0. So we take this first number, whatever it is, we don't know, this first factor here, set it equal to 0. We take the second factor here, set it equal to 0, and we solve for x. The opposite of addition is subtraction. The opposite of, yes, so let's subtract 1 for both sides. These cancel. We get x is equal to -1. Now let's do this one. Set x minus 1 equal to 0 over here. The opposite of subtraction, addition. Add 1 to both sides. These cancel, and we get x equals +1. So we get x equals -1 or +1. Now, it's probably a very good idea that you go back and check this. We got x equals, what do we get? -1 first? What if I check -1 in here, in the g function up here? Will that entire g function be 0 is the question. If we put -1 in here, -1 plus 1 is 0. 0 times whatever this turns out to be is going to be 0. Now, let's take our +1 and plug it in here. 1 minus 1 is 0. 0 here times whatever this is 0. So yes, both of those work. So the values that are not in the domain, because they cause division by 0, are -1, +1. Any questions on this particular topic? So let's take a look here. We are now going to start talking about composition. In this problem, Alex gives us composition in workable form. So we can see how to use it in workable form first, then we can then do another topic where we're putting it in workable form and then working with it. So I'm looking at those progressions. The functions R and S are defined as follows. R of x, in other words, the y value of the R function at a particular x value is given by this, 2x minus 1. S of x is given by -2 times x squared minus 2. Find the value of S of R of 3. That's usually how it's read. So what I do with these problems is anything having to do with the R function, I make sure I write it straight across. And in the R row, the R function row, anything having to do with the S function row, I write it in the S function row. Now that's not really super necessary in this problem, but let me show you another problem that we're going to do in a moment. It becomes super necessary in this problem because we've got a Q here and a Q here. We've really got to keep everything organized. It makes math easier, I think, not more difficult. Whoops, sorry for that. Let's go back and do this problem. So we want to find the value of this. I wrote it down here. And it's really nice. So first, they're asking us to find the what. You want to go inside in the innermost parentheses first, according to PEMDAS. Please excuse my dear Aunt Sally. So we're going to do what can't, really there's nothing to do with just 3. So we're looking at R of 3 here. So what's R of 3? In other words, what's the y value of our R function when x is 3? You go to the R function, we plug in 3 for x. What do we get? Well, R of 3, I'm trying to keep the notation the same so I know where to go. R of 3, we're taking 3 and plugging it in for x here. So we get 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. So we take out this R of 3 that we just found, and that's all we take out. We take that out, this goes away, and we put in 5 in its place. And we have this parenthesis and that parenthesis still there. So what is the y value of the S function when x is equal to 5? So now we're going to use the S function. So we're going to work in that row and we're going to write this as S of 5. So this means we're plugging in 5 for x into the S function. So we get -2 times, we're putting in 5 for x, that's the x inside here. So we're putting 5 in for x. If it were negative, you would want to make sure to do this. I just do it all the time, so I don't have to miss. It makes me more accurate. So I put 5 in here, put parentheses around it, and then I have to square it. And then subtract 2. PEMDAS tells us to work with parentheses first. There's just the 5 in parentheses. Can't really just do anything with just a lonely 5. So the next is exponents. This exponent of 2 tells us we want 2 of these 5s multiplied together. An exponent tells us how many of the base, which is 5, to multiply together. Exponents are a mathematician's way of indicating repeated multiplication. So we want 2 of these 5s multiplied together. That would be 5 times 5, which is 25, minus this 2. So let's just do the calculation. We do multiplication first before subtraction. -2 times 25 is -50, minus this 2. The final answer is negative 52. And that's what they were looking for here. Any questions on this particular topic? It's a good one. I would encourage you to do that one early. Try to do them in a similar order to the way I do them, because that's probably makes the most sense. Let's take a look at, let me see. Yes, we're working our way up. And you will see in this problem that now they're saying find the following. They've got this open circle here. They do not have workable form. We need to put it in workable form to get it to look like the last problem that we did. So Q of x is x squared plus 5. R of x equals the square root of x plus 7. What are we asked to do? We're asked to find the following. R composed with, that's how that's read, composition, composed with. That's what that symbol is, a composition symbol. So we read R composed with Q at x equals 2. This one we read Q composed with R at 2. You will notice the answers are not the same. This means that composition is not commutative. Addition is commutative because we can add in any order. Multiplication is commutative because we can multiply in any order. Composition is not commutative because we don't get the same answer. We're not guaranteed to get the same answer. So order matters here, very much so. So we're going to convert these to workable form first. The way to do that is we looked at that a little earlier when we did the introduction. You start with the first letter, which is R in this case, and then put a parenthesis. Go to the next letter, write it down. In this case, it's Q, right here. Write it down, parenthesis. Put your X in next. So it's the first letter, second letter. This could be a variable like X, or it could be a number. Whatever it is, you put that in next. And then you just close off those two parentheses. And now it turns into what looks like what we did last time, meaning in the previous problem. We've got our G of 2 there. What do we have in the previous problem? We had SR of 3, very similar. So it turns into what we did just a few minutes ago in that same type of form, in that same form. So we work inside the parentheses first. This is Q. We want Q of 2. So I'm going to go to the Q row and do any work I want to do with Q, I'm going to do in that row. So we want Q of 2. That means we're going to take this at what's inside here is X. So we're going to plug in this 2 for X here. So we get 2 squared plus 5. Doing the calculation, 2 squared means 2. We want 2 of these base 2's here, right here, multiplied together. So we want 2 times 2, which is 4, which is 9. So now we take out that Q of 2, just that Q of 2, and we replace it by 9. We still want the R in the outside parentheses. We replace that Q of 2 by 9. Now we want to go to the R row and figure out what R of 9 is. Here's the R row. R of 9, meaning what's the Y value of the R function when X is 9? So we're taking our 9, which is our X, plugging it in here. We get square root of 9 plus 7 equals 9 plus 7 is 16. The square root of 16 is 4. So now we now just found that R of 9 is equal to 4. So the answer is 4 here. So we take and put the 4 here for the answer. Let's do the other one. We have another one to do here. Q composed with R of at X equals 2. Q composed with R is your Y. You want the y value of the q composed with the r function at x equals 2. All of this is acting like y here. How do we write it in workable form? Go from left to right, q parenthesis. Whatever this first letter is, write it down, put a parenthesis. Whatever the next letter is, write it down, r parenthesis. Then 2, close off the parentheses. So now we go inside here and work inside here and find r of 2 first. What's the y value of the r function when x is 2? So we want to go to the r row. We want to use this row, r of 2. That means we take this 2, plug it in for x here. We get square root of 2 plus 7. Square root of 2 plus 7. 2 plus 7 is 9. Square root of 9 is 3. So we take out the r of 2 and put 3 in its place. We're taking this out right here, this r of 2, and putting 3 in its place. We still have this q, and we still have this outside parenthesis here. And 3. Find q of 3. Q of 3. That means we're going to take 3 and plug it in for x. So we get 3 squared plus 5. 3 squared means we have 2 3's multiplied together. 3 times 3 is 9. Plus this 5. 9 plus 5 is 14. So that's Q of 3 is 14. That means we're done now. So this answer is 14. Any questions on this particular topic?
I have a quick question.
Sure.
So I might have missed a piece of information, or I'm just a little bit confused. Don't really understand, I guess. Let's say like it says Q and in the parentheses is a 2 and then R parentheses 9. Where do you get those numbers from?
So are you talking here?
No, so more like upwards, I guess. So kind of like
Up here?
yeah, so there's like a 2 in a parentheses and a 9 in parentheses.
Okay, here?
Yes.
Okay. So let's go back and take a look at that. So let's see. Let's back up and look at this first one here.
Okay.
So do you understand how to get this workable form here?
Yes.
Okay, so let's just review for everybody's sake. You want to take, and maybe I can mark this up a little bit here, just so you can see. You want to take this guy, and I suppose you could say this guy. Okay, so you take whatever this variable is. Could vary. It's going to vary depending on what problem you're working on. You take that first, write down that r. In this case, it's r, whatever it happens to be. You write down r followed by a parenthesis. Then you take this number. In this case, it's q. Write it down followed by a parenthesis. Then you take this number, write it down, and you close off the parentheses. That's how you get. So we've got to abide by PEMDAS. We go inside these parentheses first. I mean, we can't just do something with the innermost parentheses, which is a 2. So we go inside these parentheses and find G of 2. Actually, sorry, it's Q. It's Q of 2. We want to find Q of 2. So finding Q of 2, this tells me we use the Q function. This right here, Maybe this will make more sense if I do this. Let me get a different color. Let's see, how about blue? This is your x. What's inside the parentheses here? This is an x. Okay, that's an x inside there. So we want to do this first. We want to find the value of the Q function when x is equal to 2. So that means we're going to use the Q function. We want to find Q of 2. So I labeled this with Q of 2. We want to use this top function here. And x is 2. So we're going to use this top function. So if we go over here, we see the first term on this side, we see our rule here, if you will. This is a rule that says we take our x, which is 2, and we square it. 2 squared. Plus, there's a plus 5 here. So we write down plus 5. So 2 squared is 4. Plus 5 is 9. So Q of 2 equals 9. Does that make sense?
Yes, I think I was just thrown off a little bit, and no, that really helped. Thank you.
Anybody else have any questions? You're welcome. Please ask questions, because I don't want a small thing to keep you all from being able to do well in this course. And sometimes it's amazing in my life when, if I had known something small, man, I could have done so much. Or if I had the, you know, if I had the courage to ask, man, what I could have done, because I found out later it was a very small thing, but it resulted in big things. So yeah, thank you for asking. Very important. Okay. Any other questions before I leave this particular topic? So let's go on. Let's take a look at this. Let's look at this one. So what are we asked to do here? And let's see. I don't want to spend a lot of time talking about this because this is really the same topic as we did before. I want to do something though. I'm trying to purposely cover up the answer. I want us to look at this. Now, let me see here. Think about what I want to do. See if this will work. I want us to take this one right down here. I don't want to give too much away. I'm not going to be giving that one away. I want us to take this and write this in workable form. Let's take this and write this in workable form. Anybody want to take a stab at writing that in workable form? The form we have now right here, it's quite hard to work with this because of the open circle. How would we write it in workable form so it looks more like this? But this is the workable form for the top one, not the one we're doing. How would we write this in workable form? Anybody want to take a stab at that? I mean, I'm not thinking about, well, somebody asked a question and or I don't think about names when you ask questions. I don't think about names when you try to answer a question. I don't really even think about names in the classroom when I do this. So I certainly don't do it in the remote environment. So how could we get the workable form here? What would we do? How could we get the workable form of this? What would we do? What do we start with? We go from left to right. What's the first thing that we write down? What's the first letter that we write down here? Going from left to right. Well, what's the first letter that you see in this expression?
W.
W. So we write down W. And I realize I need to go back and get my special tool here to write down W. And then what do I do? I mean, we can emulate this if you want. After you write down the letter, you want to write down a parenthesis. After each letter, the next letter is U. You write down U. And then parenthesis. So you want to write down a parenthesis after each letter. And then what's your number, or it is -4. So we write down -4. And then we have to close off the parentheses. So this is what we have now. We have to close off those parentheses. So how many parentheses do we have? 1, 2. And that is workable form. So you will see that that's how I got workable form. This one is just the same. Here's this. We write down U. Our first variable, if you will, or our first letter. And then we write down the parenthesis. Then our second letter is W. We write down a parenthesis. What's over here acting like our X? -4. And then we have 2 parentheses here that need to be closed off. And that's what we do. So that's how we get workable form. This really makes it so much easier. Looking at this, it's like, what do I do? You know, it's not W times -4 times U times -4. That's not what it is. So our notation there isn't really helping us a lot. So we want to convert it to workable form. So once we've got those workable forms, we can work with them pretty easily. Now we have U and W here. So anytime I'm wanting to find U of something, I'm going to use this row. And anytime I want to find W of something, I'm going to use this row. So here's our workable forms. Let's start. We go inside first. W of -4. So that tells me I want to be in the W row, and I want to find out the Y value of the W function when X is -4. So I want to find W of -4. So I'm going to plug in -4 for X here, get -5 times -4 minus 3. This negative times negative is a positive. 5 times 4 is 20. Minus this 3 is 17. So I take this out, W of -4, and replace it by 17. Leaving me with U of -17. In other words, find the Y value of the U function. Okay, so I'm looking for the Y. I'm really looking for the Y, the output of the U function, when the input, which you can consider to be X, is 17. So this is the output, this is the input. So we can take this, find U of 17. So we go to the U row and find U of 17. That means we're going to take 17 and plug it into the U function for X. And we get -2 times 17 plus 5. So we want to multiply first according to PEMDAS. -34 plus 5 gives us -29. So I go back down here. I just found U of 17 equals -29. So we want U of 17. It equals -29 is what we found. So I copied that down here. So that would be this first answer up here. So next, let's look at this one. W of U of -4. Go inside here, according to PEMDAS. U of -4. Working in the U row now, wanting to find U when x is -4. So we take this -4, plug it in for x there, get -2 times -4 plus that 5. And this becomes negative times negative is a positive. 2 times 4 is 8, plus 5 is 13. So u of -4 is 13. So I take out u of -4, replace it with 13, still have this w left, still have this parenthesis left. Now we're looking for w of 13. Find the y value of the w function when x is 13. So we take and go to the row this time. Over here, w of 13. We're going to take this 13, plug it in for x here, and get -5 times 13. We're putting the 13 in for x, so -5 times 13 minus 3. So -5 times 13 minus 3 turns out to be -68. So -68 goes in here. And again, if you notice, we've got u composed with w here, w composed with u here, and we're evaluating both of them at -4. You notice these numbers are not the same. Again, showing that function composition is not commutative and order really does matter. Any questions on this topic? So let's go on. I didn't mean to do that one all the way, but there's really no harm in that, so that's fine. So now we're going to switch gears a bit. We're not going to be talking about composition. We've finished talking about composition for today. And really that's all. We will talk about composition in another objective or two when we get to inverse functions, because they come up in inverse functions, which is why we study them. And so we're not going to talk any more about composition today, but we will soon. What we want to talk about now is just how do we look at functions which have a variable in the original function, which is stated that the function is defined by f of x equals 4 times 7 over 3, over x minus 3. This x really represents the word input. And in this setting, I feel like we need to really look at it as has the word input to really understand what to do. So you can take out these x's here everywhere and replace those x's by the word input. So f of x, we can write out the word input, equals 4. Now we see an x again. Let's write out the word input. Plus 7 over, here's x again, write down input, minus 3. It will cause less confusion if you do that. Notice we have our original function given as this, but notice what's acting like x here. X is what's in parentheses right after that f. What's in parentheses here? Y plus 1. Oh, gee, how am I going to deal with that? So it's best to, in a situation such as this, to write out the word. Instead of looking at the function in this form, actually rewrite it by writing out the word. Every time you see an x, write out the word input. Otherwise, it's confusing for me to do it in my head if I don't write it out like that sometimes. I want to be 100% accurate too. So we are told that our input this time is y plus 1. So we're told to find f of y plus 1. So I copied it over here. What's inside the parentheses is our input. We can't even call it x here because you got a y plus 1 here. So we want to just treat this as the word input. What's inside the parentheses here. We want to treat that as the word input. And then this F here is our output. We want to find the Y value of the F function for the input Y plus 1. So our input, what replaces the word input now, and what's inside these parentheses is always the input. What replaces the word input now is Y plus 1. So F of input, really, and I didn't write that down here. I just wrote it as F of Y plus 1, but that is the input. So F of input, in this case, the input's Y plus 1, so I took Y plus 1 and put it in for input. So I guess if we look at it like that, I really did what I wanted to do. Every time we see the word input here, we want to put in Y plus 1. So this is equal to 4 times input. 4 times what's our input? Y plus 1. And in parentheses. Plus this 7 divided by, from here, we see the word input again, but our input is Y plus 1 minus this 3. So according to PEMDAS, now we want to make sure we simplify this. You do not, in this class, want to cancel terms. So for example, I don't want to cancel this one with this one. Can't cancel terms. In algebra, you can cancel factors. That's why we spend a lot of time working on factors. Factoring. Factoring is really important for that reason because we can cancel factors. We just can't cancel terms. And in addition, according to PEMDAS, a fraction bar is in that P, is incorporated in that P. So we want to work with the numerator separate from the denominator, and only at the very end consider if there's any cancellation that we can do. So this is multiplication over addition. So let's distribute 4y plus 4 times 1, which is 4, plus this 7. Here in the denominator, y, 1 minus 3 is minus 2 here. It's negative 2, which we can write as minus 2. Up here, we still have some numbers to combine, that 4 plus 7, which is 11, but we've got to copy over the 4y as well, and then the plus sign. So 4y plus 11. So this is 4y plus 4 plus 7, which is plus 11. And copy over the y minus 2. I cannot cancel those y's. They're participating in terms. Terms are added. This is added. If you wanted to see if you could cancel those y's, what you could do is you could put a number in for y. What if we put 1 in for y? Let's say we could cancel those y's and get 4 plus a negative 11 halves. Will that work? So 4 plus a negative 11 halves, if I figure out what that is, for just to kind of give you an idea of what I'm doing, 4 plus negative 11 halves, and then negative 11 halves, math frac that, I get negative 3 halves. That means for every number I would plug in for y here, I've got to get an answer of negative 3 halves. Okay? What happens if I put in 0 for y? That would wipe out this term. It would wipe out this term, and I would have a negative 11 halves left. That's not negative 3 halves. So that means you cannot cancel terms or parts of terms. You can only cancel factors. So I encourage you all just to factor. We spend so much time factoring in this course. You're not going to get the right answer if you cancel just terms. If you cancel terms, not likely to occur. I mean, under rare occasions it may occur, but it wouldn't be the correct written work. So, any questions on this particular topic? So let's take a look at where we're really going with what we just did. I felt without doing that topic that this would be too much of a leap, so I wanted to include that topic when I set up the ALEKS course. So I want to take a look at this. These are very important, what we're talking about. These are used in business calculus. I teach survey of calculus here, so I've taught this many times, finding difference quotients. And they come up in survey of calculus is really business calculus. They come up in calculus 1. And it's important to you know, for this course is a survey. This is a gateway course. It's actually known as that in the state of Arkansas. And so what that means is it's for students going in all kinds of different directions. So we touch on a lot of different topics that you may or may not see in the future. But what you might see is some of the processes that in the future that we use in this course. So I want to look at this problem. Find the difference quotient, and I'm sorry that this isn't super clear because of how I did this, but I thought it was important to do it this way. Find the difference quotient. Now notice what we have above the fraction bar is a difference because we have subtraction, and all of this can be viewed as a quotient because it's the numerator divided by the denominator, which is a quotient. So really finding the difference quotient where h is not equal to 0. You can't have division by 0. The whole denominator can't be 0, and the only thing in this denominator is h. So that's why it says where h can't be 0. For the function below, f of x equals 4x minus h. So we want to find this difference quotient. There's really 3 parts to that process. There's finding f of x plus h. In other words, finding the value, the y value of the f function when the input is x plus h. Then after we get done with that, we can then subtract off f of x. Well, we know what f of x is. It's just 4x minus 8. And then after we get done with that, we can divide by h. So that's what we're looking at here. Now, what does this difference quotient represent? And I wish we had time to go over this, but we really don't. This difference quotient here, it represents an average rate of change. And in one of the interpretations of slope is average rate of change. And if you look at this function that we're given, it's in y, that stands for y on that side, f of x, equals 4x minus 8. That is in slope-intercept form. What is the slope? It is 4. That's the answer. But unfortunately, you can only use this kind of analysis if you're talking about a linear function given to you in slope-intercept form. So it makes sense that the answer is 4 for this problem. So what do? First of all, I would take this function that we're given here and write it with the inputs in it, the word input instead of x. So I take out these x's, the x here, and write this as f of input. And what is f of input equal to? It's equal to 4 times, see the x, take that out and put in the word input, minus 8. So that's what I would do, because we're going to use we're going to start by doing this first. And what is our input here? Our input is x plus h. So we want to find f of x plus h first. How do we find f of x plus h? Well, our f function, we already wrote out with the word input in it. Our input now is this x plus h. What's inside the parentheses now is x plus h. So we want to take this x plus h and plug it in for the word input. When we do that, we get 4 our input, which is x plus h. We're plugging in x plus h for the word input here. Because here's our word input, and what's inside the parentheses is x plus h, so we're plugging that in for input. So we get 4 times x plus h minus 8. Now what do we get? We can multiplication over addition. We can distribute 4x plus 4 times h minus this 8. And we can't combine any like terms because these variable portions are different. So we leave it like that. So what I realized about this is the hardest step of all for these problems is that if you want to look at this as f of input by just taking the original function here, putting in inputs, the word input for x. Then what do we have inside? Now notice inputs, what's inside the parentheses. What's inside the parentheses here? X plus h. So we're going to put in for this right here, this f of x here is really what we're doing. And that's why I'm using the word input, because it's too confusing. What do you put in for x? You're really putting in x plus h, but that is too confusing. So I don't think that that's a super good way to do it, especially if you're starting out. So that's why I recommend that you do it like this. Okay, so what do we have inside the parentheses here? X plus h. So we want to put in x plus h here. I just copied it down here. We want to put in we copy this 4 down. What do we put in for input? We're putting in x plus h for input. Copy it down here, and minus 8. And I think you can all handle that. So that's what you want to do. After we figured out what f of x plus h is, and we've completely simplified that, we then want to do our next step, which is subtract off f of x. You want to make sure you're doing it going according to PEMDAS here too. You don't want to divide by h yet. You want to subtract off f of x. So subtracting off f of x is easy, because when you subtract off f of x, first let's make sure we're copying of x plus h, which is all of that. This here just goes down right here. And we subtract off f of x. Well, subtraction. What's f of x? It's just stated right here, 4x minus 8. In parentheses. Because you have to subtract off both of this 4x and subtract off this negative 8. So you want to make sure you get your signs correct, and that's the reason why it's in parentheses. So now let's see if there's anything we can do. We just copy over the first part here. This is a negative sign. It's really -1 over, it's being multiplied. It's multiplication over addition, because subtraction is adding a negative. So you can distribute the negative sign through, giving us negative 4x. Negative times negative is a positive 8. So that's where we're at. Now, what can we cancel? So we will be given a difference quotient problem, has a written work problem on your test number 2. It's important that I can see the numbers underneath when you cross them out. So you might want to write extra dark for this problem and then lightly cross them out so I can see what you're crossing out. So it will be the next I'll talk about that more. It won't be one quite this basic. It'll be one like we see on the next topic. So after you're done distributing, you want to cross out. Generally best to go from right to left. +8 minus 8 gets crossed out. -4 plus 4 gets crossed out. What are we left with? Just 4h. Then what do? We've only done the difference. We haven't done the quotient part yet. So we still need to divide the entire numerator by h. So we wanted, and we can write that as this entire difference quotient here, f of x plus h minus f of x over h. So in the numerator, we have 4h. In the denominator, we're dividing by h. H divided by h is 1. 1 times 4 is still 4. So when you cancel, it's best to have a reason you're canceling, not just assume you can do it. Otherwise, you might cancel incorrectly and miss a problem. So I can cancel these h's because h divided by h is 1, and 1 is the multiplicative identity. Any questions on this problem? So what I'm going to do now is, and I would encourage you to work ahead on these problems. I don't have enough time to go through this last problem because I got quite chatty at the beginning of the class, but I thought we needed to talk about some of those things. And this isn't due until Thursday night. So I'm going to hold off on this until Thursday and go over this one problem. You can work on all of the other topics in this objective. So when you come to class on Thursday, this is the only one that you have left to do. So I'm going to come back up. I don't want to speed teach this topic. That would not be very much fun for me and probably hard to understand for you. Yes, I will be doing a review as well, Blair, and it will be recorded. Pending, hopefully I won't have any technology issues. So let me go ahead and stop the recording. I need to take attendance.